Alrighty, in this video here, we're going to be talking about 7.3 logarithmic functions and their graphs. All right, so logarithms are just a way that we can actually solve exponentials. So in the last video, we raised it by a certain fraction power, rational exponent, basically. And then I had said that there is another way to solve those. And today we're going to be looking at those. So when you're kind of investigating the section, the big thing is how a logarithmic function works. If given an exponential, let's say x equals a to the power of y, we can rewrite it, and it can actually go both ways. I can take a logarithm and turn it back into an exponential, but I can rewrite this as y equals log with a base of a of x. These two are the exact same thing. So depending on how the function looks, it might be easier to solve it as an exponential. It might be easier to solve it as a logarithm. This is a big thing to note because you'll be seeing it pretty much in the rest of your math days, and they'll kind of expect you to know this. All right, a couple of other little facts that come off of this. So little notes. So if you have log base a of 1, meaning if you have log of anything and it has a 1 inside, it's automatically going to be the answer of 0. And it's because if you rewrite this as this, you get a to the 0 power, and we know all things raised to the 0 power is equal to 1. The next thing to note is if whatever the base is, if you get the same value here, the answer is going to be 1. And again, it's because a to the 1 power will always come back out as itself. So there's a couple of little elementary logarithms is what they call it. And then a couple of little ones is if you have log base of a, and you have a here, if it is whatever it's raised to, if these two things are the same, the answer is just going to be x. And it's because if I have a raised to the log base a of x, these two a's will also become x. So this kind of goes both directions here. And in reality, when we get into more logarithmic rules, these exponents right here will go here. So then we know that this is equal to 1. So this ends up being x times 1. Different way to approach it. Another thing you might see is what they call a common log. So if you see just log of x, there's basically a base 10 there. So if we don't write it, there's an imaginary 10. We also have a natural log. And instead of saying log base e of x, we'll just say ln of x. So if you see ln, no, it's basically just log base e. And it actually shares the same little rules. So the natural log of 1 is still 0. The natural log of e, since they'll technically be the same, is equal to 1. The natural log of e raised to the x, just like that one, is x. And then because of this, e to the natural log of of x is equal to x. So natural logs carry the same rules that the logarithms do. And that's pretty much what this section is all about, is just kind of rewriting things to be able to solve or simplify something a lot easier. So let's get into some problems. So today we're going to be on page 483. We're going to look at number 1. Number 1 says 625 equals 5 to the 4th power. And it says write the following equations in logarithmic terms. Basically, what you want to do is just kind of note a few things. Always remember this rule. Going from an exponential to a logarithm, if you can remember it, then you can just plug in all the information. So remember, we wrote at the very beginning, x equals a to the power of y. Can go both directions here as y equals log base a of x. So when I'm looking at this, I'm basically stating that x is equal to 625, a is equal to 5, and y is equal to 4. Because that's my x, that's my a, that's my y. Take that, rewrite it. So this will now become 4 equals log base a, which is 5, of x, which is 625. And that's all you have to do at the very beginning. Alrighty, let's look at another one like this. Let's look at number 7. Number 7, it gives it to you as 4 to the power of x equals 31. It's out of order, but it doesn't matter because 31 is still your x, your a is still 4, and your y is actually x. So when I rewrite this, this becomes x equals log of 4 of 31. All right. So that's pretty much how you start the homework. And then from that, it does ask you to graph. I did call my company, or not my company, but the company that does the program for my calculator, and their system is actually down. So hopefully it'll be up and running on my next video I make. But to plug in, or basically what you're doing in the homework is they're going to give you a question like 37, and they're going to say f of x equals log base 2 of x minus 1. And remember exponentials, side note, so exponentials, when we learned it in 7.1, kind of went like this, or it went like this, right? You had exponential growth or decay. Well, logarithmics do something like this. So like that, or like that. So basically, instead of it being the x-axis doesn't cross, it's the y-axis that it doesn't cross. All right. So this being a base 2, it's like greater than 1. So the way that's approached, it's a growth. So if it's less than 1, it's a decay, and if it's greater than 1, it's a growth. So basically, I know my function will be increasing from left to right. So I know I need to go this direction. The minus 1, remember this right here, anything in parentheses deals with your left and right. And if it's plus, I'm left, and if it's minus, I'm right. So originally you would cross at 1, but since I'm going right 1, I'll actually cross at 2, but it'll still look something like this. And on yours, you just have to match it just like on the homework. So if we look at another one, let's look at 44. You get f of x equals log base 2 of x. And in this situation, again, nothing's changed, so it's actually going to go through 1. So it looks just like that. So very similar to exponentials, just opposite basically, or it's inverse reality, because the logarithmic is a exponential or inverse of exponential, and then exponential is also an inverse of a log. Different question or different topic for a different time. For now, let's now evaluate some of these. So at 46, we're going to look at log base 7 of the square root of 7, and you're asked to do this without using a calculator. So a couple of things you need to remember: that a square root is written as log base 7 of 7 to the 1/2. And earlier there was a rule that said log base a of a raised to the x is equal to x. Well, this is that situation. So 1/2 would be your answer without a calculator. Done. 47, you have log base 1/2 of 4. So in this case, it might be a little bit easier to rewrite it using our little law rules, which was a to the y equals x. Goes both ways. Y raised to the log of a of x. So in this case, I don't know my mystery, so I'm going to actually call it y since that's what this is. So this is basically going to be 1/2 to what would give me 4. Well, a couple things I can look at this and I can go, well, if y is negative, I can say, well, this is 2 to the negative y, right? Because I can flip the fraction. And then if I say, hey, if I square this to the negative y, I'll get 4. So now I get 2 to the negative 2y equals 4. Maybe I went in the opposite direction. I did. I went in the opposite direction here. Hold on. Mathematically, I need to turn this one into that. So this is 1/2 y. If I raise this to the negative 1, there we go. And then I go, well, this is the same thing as 1/2 squared raised to the negative 1. So then I get 1/2 to the negative 2, because a power to a power, you multiply. And so by looking at this, I can then say, well, y must equal negative 2. Again, basically solving these without a calculator. All right. Let's look at another one. Let's look at number 49. 49 is log base 3 of 27. Again, we'll assume it's equal to y. So if I, again, use this approach, I can say, well, 3 to the what will give me 27. And then I know that 3 times 3 is 9, times 3 again is 27. So 3 cubed will be 27. So I see that y is equal to 3. All right, let's look at another one. Let's look at number 56. 56 is log of 0.0001. Remember, if there's no log there, there's an imaginary 10. So we'll say this is equal to y. So we'll say 10 to some power must equal 0.0001. To help you out, this is the tenths, hundredths, thousandths, 10,000ths. So that's 1/10,000th. So to make this look like that, I can say, all right, well, this is 10,000 raised to the negative 1. And then this will become 10 to the 1, 2, 3. So 10 times 10 is 100, times 10 again is 1,000, times 10 again is 10,000. So that would be to the 4th power, so negative 1. So that would be 10 to the negative 4th power. So I can see that y is equal to negative 4. All right. Try to put this all in the same little section here. Let's look at 60. Log base 3 of 1. Again, on this one here, regardless of what this exponent is, we had a rule of log base a of 1 is equal to 0 automatically. So the answer to this is 0 regardless. And you can check that, right? 3 to the 0 equals 1. So then you know 0 does equal 0. Alrighty, so let's see, I think, oh, okay. Now this next part is going to be hard for me because again, that computer program is down for me. But the next one says solve the following logarithmic equations using a calculator if necessary. So I'm going to get it basically almost to the point that all you have to do is just kind of plug it in. So what I'll do is I'll solve this with you without giving you the exact answer, and then you'd have to plug it into your calculator to get the exact answer, which we can do together as well. All right, so to solve these guys, again, when given as a logarithm, we'll use that log rule. Again, I'll write it down until y'all feel comfortable with it. So y equals x gives you y equals log base a of x. All right, so again, if there's not written there, there's an imaginary 10. So this becomes 10 raised to the 2.1 equals 3x. So then all I have to do is divide by 3. So plugging this into my calculator, I see that I get 10 raised to the power of 2.1 divided by 3 gives me approximately 41.96. Oh, This was question 76, by the way. Right. So yeah, so I don't need a fancy calculator to do this with you. So we'll do 78. Natural log of x plus 1 equals 3. Remember, this is a base e. There's a base e right here. So this becomes e to the third equals x plus 1. So I would subtract 1 on both sides. And so I would see e to the third minus 1 equals x, which is, couldn't tell you. So this is going to be e raised to the third minus 1. And I get 19.09 for that one there. And then last one, and you should have everything you need on this homework. So pretty easy homework here. So 84 is log base 9 of 2x minus 1 equals 2. Again, using that log rule, it's going to become 9 squared equals 2x minus 1. I should be able to do this with that calculator. 9 squared is 81. 2x minus 1 plus, oh, if it ain't one thing, it's another when it comes to technology. Give me 1 second. There we go. All right, so plus 1 there. So that's going to be 82 equals 2x. Divide that by 2, and I get a straight 41. And that's pretty much it for 7.3 there. Yeah, that's all. So if you need any more assistance or help on that, feel free to keep emailing me. Other than that, that's all that I have for today. I'll see you in the next one. Bye for now.